Welcome to the Explainer. Have you ever looked at a jumble of letters and numbers in a math function and thought, how is this supposed to be a line? Well, you're absolutely in the right place. Today, we're taking apart the machinery of linear equations and giving you the exact tools you need to confidently graph them. We're going to break down the anatomy of that line piece by piece so you can build it yourself.
Here is our roadmap for today. We're going to meet the linear function, decode the slope, find the intercepts, go over step-by-step graphing, and finally, we'll actually practice graphing together.
All right, let's jump right into part one, meet the linear function. So, what is a linear function? It's basically a function defined by one absolute rule. It has a constant rate of change, and that guarantees our graph will never curve, bend, or zigzag. Every single time you graph a linear function, the result will be a perfectly straight line. Honestly, that predictability is what makes them so fantastic to work with.
The most common way you're going to see this expressed is in the slope-intercept form. Think of it as our blueprint. Y equals mx plus b. The y and x just represent the coordinates on our graph, but the m and the b, those are the real stars of the show here. They represent the two vital tools we need to understand to actually draw our line.
Let's move on to section 2, decoding the slope.
Slope basically measures how steep a line is. You've probably heard the famous phrase, rise over run. It's a map that dictates exactly how a line moves vertically, that's the rise, versus horizontally, the run, from left to right. It is quite literally the directional map for our straight line.
Now check this out. We can quickly categorize the four possible shapes our line can take based entirely on the slope's value. If the slope is positive, the line rises upward as you move right. If it's negative, it falls downward. A slope of 0? That means the line is perfectly flat and horizontal. But look at that last row. If a slope is undefined, the line is perfectly vertical. And crucially, a vertical line is actually not a function at all.
Okay, on to section 3, finding the intercepts.
With our direction set by the slope, we need an anchor point. There are two types of intercepts. The y-intercept is the value of the function when x equals 0, meaning it's the exact spot where a line crosses the vertical y-axis. Conversely, a line can have an x-intercept, which is where it crosses the horizontal x-axis, meaning y equals 0 right there. Knowing the difference between these two is super important so you don't mix up where to place that very first dot.
But here's a pro tip. For most school algebra, the y-intercept is your starting block. It's almost always the one used first when graphing a line. So for our purposes today, we're going to focus entirely on the y-intercept because it acts as the official starting line for our whole graphing process.
Which brings us to section 4, step-by-step graphing. Now that we understand our m and our b, here is our foolproof recipe. Just 3 steps. Step 1, plot the y-intercept first. Bam, starting dot. Step 2, use the slope, that rise over run we talked about, to find another point on the graph. Step 3, draw a straight line through those 2 points. That is literally it. It is the perfect recipe for graphing any linear function in slope-intercept form. Let's put this blueprint into action with section 5. Let's practice graphing.
Imagine you're taking a test, and you get this exact equation. Y equals 2x plus 1. Where in the world do you start? Well, we have our blueprint, y equals mx plus b, so let's match up the parts and follow those 3 steps.
Step 1. We need to identify our starting anchor, the y-intercept, which is our b value. If we look at the very end of our equation, we see a plus 1. That plus 1 tells us exactly where to make our first mark on the blank graph.
Because our b is 1, we know that when x is 0, y is 1. So we go straight to the vertical y-axis and plot your first point right at the coordinate 0, 1. Our anchor is officially set.
Okay, step 2 requires us to identify the slope map to find our next point. Looking back at our equation, y equals 2x plus 1, the number attached to the x is our m, so our slope m is 2. To use this as a map, we can just think of the whole number 2 as the fraction 2 over 1, and there is our rise over our run.
Because it's a positive 2 over a positive 1, our movement is totally locked in. Starting directly from our anchor point of 0, 1, we rise up 2 spaces vertically, and then we run right 1 space horizontally. Right there, we plot our second dot.
And looking at how the experts break it down in the text we're analyzing, plotting that 0, 1 intercept and applying the slope to move up 2 and right 1 is exactly the right procedure. It's a completely systematic, repeatable process.
Finally, step 3. We've got our starting anchor, and we have our second point mapped out by the slope. Now, just take out your ruler and connect those two dots with a straight line, extending it outward in both directions. You did it! You successfully visualized the equation. You literally turned y equals 2x plus 1 into a visual reality.
Every linear function graph is just a straight line, and its shape is completely determined by just its slope and intercept. Knowing that, you now have the exact step-by-step tools to decode any linear function, finding your anchor, mapping your rise over run, and connecting the dots. The entire world of algebra is ready for you to map out. So what complex equation are you going to confidently graph next? Thanks so much for joining me on this explainer, and hey, happy graphing!